So for this example, we're going to look at how you would solve for x when you need the quadratic function, which just means x can have two solutions. And these can look like standard quadratic functions that I can solve, but since we're using the example of the order of operations, it's a little bit manipulated. We're going to have to move it around a bit to figure this out. The first thing I'm going to do, because I'm solving for x, you'll notice I have x in the numerator on the left side and I have it in the denominator on one of the right sides. I'm going to multiply x to both sides of my equation. Now, because multiplication is of a higher order of operation than subtraction, when I multiply x to both sides on the right side, I have to multiply it to both the 7 over x and the 4. So I'm going to multiply again, multiplying x to both sides. That's going to be 3x, and that's going to equal x. I'm going to put parentheses around the whole thing, 7 over x minus 4. On the left side, I get 3x squared. On the right-hand side, when I distribute x times 7 over x, the x's cancel each other out. Anything divided by itself is 1, including x. So that's going to become 7 minus 4x. I'm then going to subtract 7 from both sides. I get 3x squared minus 7 equals negative 4x. And then lastly, I'm going to add 4x to both sides. 3x squared plus 4x minus 7 equals 0. And this is more of a standard trinomial that you've probably seen before and are somewhat used to. We then use the quadratic formula to plug it into the equation here. The basis for the quadratic formula follows any trinomial quadratic equation. I have ax squared plus bx, that should be a plus sign, plus c equals 0. It's very important. I cannot factor a quadratic unless it's set to equal 0. There are methods around that if you do completing the square, but the math gets a little different. So to make it simpler, we just always set it equal to 0. A, B, and C are constants. They're the coefficients. In this case, they're 3, 4, and negative 7. But the formula for which I set this up is that x is equal to negative b plus or minus. The plus or minus is what gives us the two solutions. Part of that becomes when I take a square of the square root of something that has been squared, it could be positive and it could be negative. So this is b squared minus 4ac. Under that square root is what's called the discriminant, divided by 2 times a. So in this case, a is my first coefficient. That's in front of the highest polynomial power, and that's going to be 3. B is 4, and c is negative 7. I would include the negative there. So my formula is going to equal x equals negative b, negative 4, plus or minus the square root of b squared. That's 4 squared minus 4 times a, which is 3, times c, which is negative 7, all over 2a, which is 3. Can simplify that. I'll move it down here. X is equal to negative 4 plus or minus. When I multiply all this through and add it together, I get the square root of 100 over 2 times 3, which is 6. That's going to equal negative 4 plus or minus 10 over 6. And then I get my two answers when I evaluate them out. One of them is negative 14 over 6. The other is 6 over 6. When I simplify those, I get negative 7 over 3 and positive 1 as my two solutions.